Okay, we're continuing with Chapter 2, and we just stopped there. So they say that you can take a data frame, create a data frame with the data frame function, and we're putting in various columns, various vectors for columns, and then this argument, row names, you can fill it in, for example, with your patient ID column. So that was one of the columns, and that can be the row names. And later on, you can refer to the row names, and so that could be useful. We'll see some examples of that. Okay, let's go to factors, which we've also covered already, and we've talked about the fact that variables can be of different types, and we have quantitative and qualitative variables, and characters, for example, strings, or even character data, and here they break it up into what they call nominal, ordinal, or continuous. So continuous is like a number, like 3.67 or something like that. Ordinal, I think we mentioned in a video before, is something where you have like first, second, third, and fourth, or good, better, and worse, or something like that. So there's some kind of order there, but they're not really numbers. And nominal is where there's no order at all. So beer types, like Asahi beer, Sapporo beer, and so on, there's no order there. We can't really say one is bigger than the other or something like that. The way he describes this, he says, nominal variables are categorical without an implied order. So by nominal, that's what he means. Diabetes type 1 and type 2 is an example of a nominal variable. So I guess there's no, type 1 diabetes and type 2, there's really no order there. Even though there's a 1 there, we don't really mean anything by that. Even if type 1 is coded as a 1 and type 2 is coded as a 2 in the data, so they just mean coded that way, it means we say, okay, let type, whenever we want to refer to type 1, we'll use a 1, and whenever we want to refer to type 2, we'll use a 2, but there's no order. We're not saying 1 is less than 2 or something like that. Ordinal variables imply order but not amount. So that's like what we said, poor, improved, excellent. So this one is less than that in some sense, but the difference between these two is not necessarily equal to the difference between these two. So that's an ordinal variable. Okay, so you can read this, but let's see, what's he doing here? So we're talking about factors and the factor function here. And so we can take this, which is type 1, type 2, type 1, type 2, is a vector, and create a factor out of it. And as we said earlier in the semester, we said that factors are stored as numeric vectors. So you can see there's a type 1, type 1, type 1. So here, and then same one here, and then same one here. Okay? And I think we said that the reason this one is coded as a 1 is not because it has a little 1 there, that's just coincidence, but because it comes first. And this one comes second, and then this is just a repeat of the first one, so it's still a 1. And this is, so we talked about this. And that's the factor function, which creates a factor. So that was for where there's no order implied here, right? But we also create factors when we have ordinal data. So like the diabetes was, what was diabetes? I forget. So diabetes is this one, and status is this one. So status is also, we'd also like to make a factor out of this, but here this is ordinal. So we have two different cases where we'd like to create a factor. One, in the case where there's no order at all, just strictly categorical. And the second one, it is categorical, but there's an order, as we've been saying. So here we have status. It was already right there. I should have seen that. And now we're going to make that into a factor. And in that case, we can use the ordered argument, set it equal to true. That's saying that there is some order here, and we'd like R to know about it. So how is that going to affect things? So they say that this will encode the vector like this. Now this looks really weird because we said before that the first one will be encoded as 1, and the next one would be encoded as 2, and the next one would be encoded as 3, and then this is a repeat of the first one, so that should be encoded the same as the first one. So at least that's true. This is a 3, and this is also a 3. But why did we start with 3? We said we should start with 1 for the first one. So if it's kind of weird, silly, but the way it works is it looks at it alphabetically, which has no meaning, right? But anyway, that's what it does. E comes first, so that's coded as 1. I'm sorry, yeah, E is the first letter in this of the first. Anyway, so E, and then I, so that should be 2, and then this would be 3, and so 3 occurs twice here. So that's a kind of a weird rule, and obviously not one that we really want to stick to. But if we don't specify anything else, and we just say order is true, it's going to do it this way. Now, if we didn't say order was true, what would it do? It would say this was 1, this is 2, this is 3, this is 1. And that's not right either, really. I'd like, I guess, I'd like the most ideal thing would be for this to be 1, this to be, 2, maybe it was right, this to be 3, and this should be 1. So that would work out, actually, if we said nothing for order, right? Wouldn't that do it? But anyway, that would be just by chance. So neither of these is actually ideal. But anyway, let me just restate this. If you set ordered equal to true, it's going to order them according to the first letter, or alphabetically, we can say. So he says, additionally, any analysis performed on this vector will treat the variable as ordinal and select the statistical methods appropriately. So there may be some statistical methods that can handle ordinal data, and they will work here. So then he says you can override the default ordering by specifying a levels option. So here's levels, and now we say we want poor to come first, then improved, then excellent. So that will be, so poor will be encoded as a 1, and improved will be encoded as a 2, and excellent is 3. Okay, now that happened just by chance before, but of course we don't want to leave it to chance. So you can do factor, then you put in whatever you're trying to make a factor of. Then if it is ordered, you'll say ordered true, and it's probably wise and probably necessary to also specify levels. Okay? All right, let's stop this, and then we'll look at some examples of this.